On the previous video, we calculated that the ordered dose is appropriate for this child. So in this video, we want to look at how much we should administer. From the first paragraph, we find that the doctor's order is 600,000 units. And then we need to figure out what is available to us. Because this medication has been reconstituted, finding the dosage strength can sometimes be confusing. Reconstitution happens when the medication is shipped as a powder. And then, according to these directions, we need to add 1.8 milliliters of sterile diluent. After we would shake that powder and diluent together, we would then have a liquid solution. The manufacturer clearly tells us that once it's reconstituted, we have 500,000 units per milliliter. And so that fraction is what we're going to use in order to figure out how much to administer. So first, by the nursing formula, desired over have times the quantity. Our desired amount is the order of 600,000 units. What we have on hand is the 500,000 units, and that is in a quantity of 1 milliliter. So I do that work on my calculator and I come up with an answer of 1.2 milliliters. Now we can also complete this same problem in proportion format. If we're going to do the proportion format, we start with the dosage strength, and so we see that there are 500,000 units in 1 milliliter. Proportions are where the same labels are directly across from each other, so we put the ordered amount of 600,000 units. And we want to figure out how many milliliters, so we put the X milliliters. We multiply on the two diagonals, and so we get 600,000 equals 500,000 X. Divide both sides by 500,000, and X equals 1.2 milliliters. Sorry, my one's a little sloppy there. The last way that we can do this problem is by the dimensional analysis. In the dimensional analysis approach, we start with what is ordered, and so we have the order of 600,000 units. And to put that into a fraction, we simply put that over 1 as a placeholder. We want the labels to cancel, so I'm going to put the dosage strength of 500,000 units in the denominator. And I put the 1 milliliter, the quantity that it corresponds to that, in the numerator. Units then cancels. Again, I do the math and I come up with 1.2 milliliters. So as you can see, your approach does not matter here. Whatever you've been using to solve problems, I would continue to use, and this problem really is just a basic dosing problem because we had already figured out that the ordered amount is in the safe range for this child.